All right, so this week we're going to finish up with section 1.2 and part of section 1.3. Section 1.2, we're going to look a little bit more at graphing calculators, and we'll talk about what it means when the directions ask you to find a complete graph of a problem. All right, so the first thing they mentioned in this section is just kind of some general problem-solving tips. Okay, just pretty much when you're approaching any kind of problem. So the first thing you want to do when you're solving a problem is read it through and make sure you can figure out what they're asking you to find. Okay? If you read the directions and you're not sure what they're asking you to find, then you're not going to know how to approach the problem. So you figure out what they want you to find and figure out everything that they give you. Okay? Write down anything that's given. Okay, after you figure out the information that's been given and what you need to find, then you want to figure out what approach you want to take to solve the problem. So if you were solving a problem where I said a person is standing 200 feet away from a building, the building is 100 feet tall, I want to know the angle from the ground where the person is standing to the top of the building. What do you think it would be helpful to do in that kind of problem? What would be a good approach? How about Ezekiel? Not specifically like, oh, we'll take the calculation, just a kind of a general idea to make what I just said a little easier to interpret. Okay, so you have all that information, you have all the distances, but how about a different way to represent everything I just said? What do you think you would do? Not sure. Help them out? Yeah.
Draw a picture?
Yeah, that's the kind of problem where you definitely want to draw a picture. Because then you can visualize what's opposite, what side is adjacent, which is important in trig, and things like that. Okay, so drawing a picture is a good way. Another approach, sometime making a list. So if I said to you for lunch, you can pick 2 choices for a drink, and you have 4 different choices of sandwiches. How many different meal combinations are there? Well, there's not that many that you could make a list. You could have the first drink with the first meal, the first drink with the second meal, and you could make a list of everything. But why might a list not always be practical? What could happen, Ian?
If there are like 30 different options.
30 or even like millions. Yeah. So if I said to you to list like all the different license plates you could have in Massachusetts, or I said to you, how many are there? Okay, that's a more reasonable question. How many? It's very easy to figure out how many, but not a good way to do it by listing them all out. You don't want to do that. Okay, so sometimes making a list. Sometimes writing down an equation, okay, like you might draw a picture of a situation and then use an equation, like maybe you draw a triangle and then use Pythagorean theorem. So it depends. Okay? Every problem's a little different. Okay? And page 13 in your book mentions even other strategies for solving problems. All right, so after you've read it, you know what you got to find, you know what's given, and you kind of figured out, you have an idea of how you're going to approach it, then you actually carry out your plan. Okay, draw your picture, plug things into your equation and solve your equation. And even carrying out the plan, there might be different ways to do it. If you have an equation, maybe you're going to draw it on the calculator and solve it that way. Okay, we'll try some like that today. Or maybe you're going to use algebra. You're not going to use the calculator. Okay, so I'm going to show you kind of different approaches to the same problem. All right, so I want to write an equation to represent that situation. Okay, it costs $15 to rent a car, and then you pay 20 cents for every mile you drive it. when I write down this equation, can anyone think how many variables I'm going to need? Yeah? Mina?
3.
Okay, can you tell me what you're thinking they would be? What's one thing you need a variable for?
The answer.
Okay, you need a variable for the answer, the total cost to rent the car. So that's a variable. And what does the total cost depend on? Yeah?
The number of miles.
It's the number of miles you drive. So we're going to need 2 variables
Oh.
in this case. Yeah, just 2. And you do have to let x equal the number of miles, because x is what we call the independent variable, and y is the dependent variable. Okay, the reason is because the cost is dependent on how many miles you drive. The cost is dependent, and dependent is always the y. The number of miles is not dependent. You know, you're going to drive however many miles you need to drive, you know, to get where you're going. And then however far you drive, then the cost depends on that. So cost is dependent. Okay. And, I mean, I could have used A and B for the variables, but why do you think I used X and Y? What might I be leading to, like, we're going to be doing in a little bit? Yeah, we're going to be doing some graphing. Okay, that's why I used X and Y. All right, so can anyone think they can give me an equation that represents that situation right there? Yep, Hannah?
Y equals 0.2 x plus 15.
Yep, perfect. There's your equation. Y equals 0.2x plus 15. Okay, any questions on that equation? All right, so now we've got our equation. We're going to use it to do a couple things. Let's use our model, use our equation, to find the cost to drive 50 miles. So Matt, if I want to use that equation to find the cost for 50 miles, how would I do it?
First you replace the x with 50.
Yep. Replace the x with 50. And now we just do it out. 0.2 is the same as the fraction 1/5. So basically I need 1/5 of 50, which is 10. Okay, so 0.2 times 50 is 10, plus 15 gives me 25. And what should I put for a label on that? Dollars. Yeah. Remember, not miles. We were finding dollars. Okay. Now I want to find out the cost to drive 100 miles. Well, if I'm just driving double the distance, can I just double the cost? No. Why can't I do that?
15 is not.
Right, you're supposed to leave the 15 out. If you double the cost, like I just said, you're gonna overestimate how much it would cost. You could double the cost for the mileage part, but you don't double the 15. Okay? So sometimes people think of a shortcut like that in their head. They're like, oh, double the miles, double the cost, $50, move on. But think about it a little more carefully. You can't do that. All right, so 0.2 times 100 plus 15. Yep, 0.2 times 100 gives you 20 plus 15 is $35. Okay, any questions on that? So in both those cases, we plugged in a number for x, and we found y. Okay. That equation right there, okay, that's what we call the algebraic representation for our problem. Okay. If you were to just tell somebody that equation, y equals 0.2x plus 15, they would have no idea that it's about a rental car problem, and that you pay 20 cents a mile and a $15 fee on top of that. Okay, so the equation kind of abstracts, takes away all the details of the word problem, and it just reduces the whole thing to just math. Okay, just numbers and letters. no context. Okay, that's the algebraic representation. All right, so now we're going to take that same equation, and we're going to say that suppose Sarah was charged $50 for renting the car. How many miles did she drive? What's different about this example? You're still using the same equation, but what are you doing different now? Curtis?
You get a different variable,
Okay, what variable are you plugging in for?
the total cost.
Yeah. Now we're going to plug in for the total cost. All right, so we're going to do 50 equals 0.20x plus 15. Okay, and I'm going to solve it the first time I'm going to use algebra. 50 equals 0.20x plus 15. Okay, Wyatt, what's my first step to solve that for x?
Subtract 15 from both sides.
Okay, subtract 15. Subtract 15. That's gone. It's all supposed to be the same color. I don't know why that happened. But it's 35 equals 0.2x. And then my last step is to divide by 0.2. Okay, so divide by 0.2. Divide by 0.2. And anybody know what that's going to come out to? Yeah.
175.
Yeah, 175. And remember, that's 175 miles. Okay, so that's one way to solve the problem. Okay, perfectly fine to do it that way. But I'm going to show you a different way using the graphing calculator. Okay, specifically using the graphing feature, not just typing the calculation in that we just did. We're going to do some totally different method. Before I show you, does anybody have an idea of how you use the graphing calculator to solve this? Maybe not like the order of the buttons to press, but does anybody have a thought about what I'm going to explain? Yeah?
Aren't you gonna do the plotting and just look at, like the thing we did last night, where we just look at where the points intersect?
Yeah, we're going to look for an intersection point. That's exactly what we're going to do. Okay, so on your calculator, you're going to type in two things. First thing you have to type in is the equation. Y equals 0.20x. Well, you could just do 0.2. 0.2x plus 15. And we want to know when that value hits 50. Okay? We want to know when does that equation equal 50. Now we already know the answer. It's when x is 175. Okay, but pretend we don't know that. When does that equation equal 50? So I'm going to graph the equation on one line. I'm going to graph 50 on another line. Then I'm going to look for where those graphs cross. All right, so let's take in 0.2x plus 15. Type in 50. And now if I do zoom 6, what's wrong? How come I don't see anything?
You're not far enough out.
Yeah, I'm not far enough out. I mean, we already know the answer. It's when x is 175. So first of all, I got to set my x max. I don't like it to be right on the screen, so I'll even go a little bigger than that. I'm going to go 200. How about x min? What does x represent in this problem again?
Number of miles?
Number of miles. So negative 10 for a minimum? Does that make sense? No. What would be a good minimum? Like what's the minimum you could drive the car? Yeah, technically you could drive 0 miles. You don't drive at all. And now, what about y? What does that represent? Cost. Well, I guarantee the cost is not going to go negative. But I want to know in this problem when the cost, how much did it cost, Sarah? 50. And I don't want that right on the edge of the screen, so I'm just going to go a little higher. I'm going to go 60. So I'm going to use that window. I'm going to hit graph. There's the cost to rent the car. That line represents $50. And I want to find where they cost. And that'll be my answer. Now what you can do is you can press trace. And you can kind of trace over and you can get kind of close and we can see where we're close. But there's an even easier way to do it. Does anybody know where the button is to calculate where they cross? That tracing thing, that's not really that accurate. Yep.
Press second, and
Second,
then the shift.
trace, and then
5.
your fifth option. So second, trace gives you that menu, and the fifth option down is intersect. Now, to use this, you're going to have to press enter 3 times. The first time you press enter, you're saying, all right, I want you to use the blue line. I want you to use the red line. Because if you had, let's say you had a blue line, a red line, a green line, a black line, all these different lines, maybe you want to find where the green and the black cross. Maybe you want to find where the red and the black cross. So you've got to tell it which 2 you want to see. There's only 2 on the screen, so there's nothing to really pick. So pick the 2 lines, and then for your guess, just put the guess kind of close to the intersection point, and the calculator will handle it from there. So it tells me the intersection point is when x is 175. Does anybody know why they have a guess? How about if I do something like this? Anybody have an idea why they give you a guess now? Yep?
Those 2 intersection points.
Because there's 2 intersection points, and the calculator is only going to give you 1 at a time. So if you have a graph like that and you wanted to find both intersection points, you have to go through the process twice. Okay? Wherever you put your guess, you're going to get the intersection point that's closer to your guess. Okay? In this case, you could put the guess anywhere you want. It doesn't even really matter because there's only 1 intersection point. Okay. So any questions on solving that graphically, getting 175, or solving it algebraically?
Question.
Mhm.
Mine has an R instead of a Y.
Instead of a y, so what you want to do is press mode. And then under mode, I guarantee your polar is highlighted. Is that what it is? Polar? Does it look like the word polar is highlighted?
No, it says normal.
It's not polar? Then I have no idea. Yeah, polar is highlighted.
Oh.
Yeah. So you want to put it on function.
Okay.
So, yep. So if you put it, just put it, go to function, hit enter, now function's highlighted. Now if you press y equals, do you have,
Yeah.
okay. Yep. We'll talk more about what that was in like March. Okay, any other questions on this? You're not seeing, did you set your window? You say your x min, your x max, your y min, and your y max?
Yeah.
Let me take a look. All right, so you should have 0.2x plus 15. Let's take a look. Looks like that's what he has. He's got 50. Let's check the window. We've got negative 200. Oh, you have negative 20, but that shouldn't matter. Your y min and y max are not the same as mine. Just set that and we'll be all set. So his y min was 60, and his y max was 80. So basically what he was looking at was this section right there. If you set your y min to 60, all you're going to see is that blank screen.
Which I said I did.
I think we did 0 to 60. Okay. Any other questions on that? You okay now?
Yeah.
Yep.
I still need a graph.
You didn't get a graph? All right. Did you put in the right equations?
Yeah.
All right. Did you set your window?
I don't know.
So to set your window, press window. And then you need to set x min, x max, y min, and y max to those 4 values.
Oh, okay.
Those are the values you want. Okay. Any other questions? Okay. And even doing it graphically, there's more than one way I could have shown you graphically. This is one way to do it on the calculator. There's other ways too. Okay. We'll talk about them at some other point. All right. So when you have a viewing rectangle, okay, when you have a screen on the calculator that shows all the important features of the graph, okay, that's called a complete graph. Okay, for my problem, if I go back to my window here, using these x max, x min, y max, and y min values gives me a complete graph. The most important thing that I want to see is the intersection point. If that intersection point is off the screen, I'm missing something important, and I don't have a complete graph. Okay, so all you have to do in the homework, if they ask you to find a complete graph and they tell you what to type in, just write down the window. Write down these 4 values. X min, X max, Y min, Y max. Okay, so let's try a couple examples and see if we can find windows that show the graph properly. So if you have anything else, you can clear it out now. We're done with that problem for now. And I'm going to type in x squared plus 10. Not sure if I mentioned this, but to get an x very quickly, just press the button right below mode. It has an x, a t, and a theta on it. Just press that button, and then squared, and then do plus 10. Now, what I'm going to do to reset my window, and so everyone's looks the same starting from this point, I'm going to do zoom 6. Okay, zoom 6 is a standard window. Standard means negative 10 to 10 on the x, negative 10 to 10 on the y. Okay, and I don't see anything. So, something needs to be adjusted on my window. Does anybody have a thought? Which one of those 4 values? I think you can just change one of them, and you'll be okay. Curtis?
I make the Y max bigger,
Yeah. What would you make it?
probably around like 15.
Yeah, 15. You'll see a little bit of the parabola, but the point is you'll start to see it.
Or whatever.
That plus 10 shifted the parabola up 10. It shifted it off the screen. So if you made it 15, I would accept that. If you made it 20, 25, 30, any of those numbers would be fine. What I wouldn't probably accept is if you said, well, let's make it, I don't know, 400. Okay, that kind of distorts the parabola a little bit. Makes it look a lot wider than it really is. Okay? Or even worse, if you said, oh, let's make the Y max like 40,000. Now you've made the Y max so big that I don't know if you can see it, it's tracing it, but it almost just looks like a straight line. You've squished it and distorted it so much that it just looks flat. So that's way too big. All right. So anywhere around 15, 20, 30, 40, 100, anywhere around that range is a good window. Okay, so let's put this back on 20 or 15, whatever you had. And that's a good complete graph. Okay, so write down your x min, x max, y min, y max. I'm just going to copy that. Put that right there. Okay, so any questions on getting a complete graph for that one? Error? And did you type in exactly what I have for y1? X squared plus 10?
The x min is negative.
Yep, you got to make sure your x min is smaller than your x max. If you make your x max smaller than the x min, you'll get a weird error. It'll say window range error. Anybody else?
I'm still getting an error from that.
Yeah, me too.
You're getting an error?
Yeah.
Let me see what you typed in.
I'm trying to look for you there.
I'm not sure, I retyped it and it seems to work.
Can you retype mine?
Let me see. Let's see what's going on. So, invalid. So hers says invalid dimension. What that usually means is under the scatter plot, somebody typed in something that they shouldn't have. Let me try to turn that off and see if it works. Yes, you're all set. Yep. So invalid dimension had something to do with a scatter plot, which I'm not going to talk too much about right now. But basically what I had to do to fix hers is her scatter plot, plot 1 was turned on. I just turned it off. So I didn't actually fix the problem. I just shut the problem off for now. That's all I did. Yeah. All right, let's take a look at another one and see if I can fix it. So this one has 2 scatter plots turned on. I don't know why all these scatter plots are on. So hers has plot 1 and plot 2, so I'm going to highlight and just shut them both off. And now you are all set. You have to fix yours.
Thank you.
You're welcome. Another one?
Mine says error.
Error? All right.
Yeah, I don't.
Let me see.
It says like the x max is smaller than the x min, which doesn't make sense. I don't know.
So hers says error window range. That means that a minimum is bigger than a maximum, which shouldn't happen. Or the other way around. So her x min is 1, her x max is 10. Is that okay? X min 1, x max 10. I'm not saying it's a good window, but that makes sense. Y min 30, y max 10. No. You can't have your y min bigger than the max.
All right.
It has to be smaller.
Okay.
That's the problem.
So how do you go about turning off these scatter plots?
To turn off the scatter plot, you just press the up arrow till you highlight the plot. I just turned mine back on. Press the up arrow, highlight the plot, and then hit enter. So when they say min, min has to be the smaller number, max has to be the bigger number. All right, how are we doing now? Anybody else still having trouble? No? You got the parabola to graph? Okay, and a lot of these things, as you get more comfortable with the calculator, you start to figure out some of these things. That particular graph that we drew, that's a parabola. And I made it a relatively simple one. Okay, in our example, A was 1, B was 0, C was 10. That's why it was x squared plus 10. And that format, that ax squared plus bx plus c, that's the general form of a quadratic equation. Okay? In graphing a quadratic, the shape is a parabola. Okay? This 2 is very important. It's what makes it quadratic. And that 2 tells me something about how many times the graph can turn. Okay? If you have a graph, with a 2 in it, it can turn once. That's one turn. If you had a graph that had an exponent with a 3 in it, okay, it has to be an exponent. An exponent of 3 means the graph can turn twice. So let me show you what happens if I change it to x cubed instead of x squared. In fact, let me, I want to make something a little more obvious. Let's do x cubed plus 2x plus 1. I think that'll work. So you should see a graph on the screen that has 2, well, that one just looks like 1. I don't have one made up already, so I'll do it like this. Okay. If I FOILed this all out, it would have an x cubed in it. Okay. I don't have it FOILed out off the top of my head. I'm just trying to show you if you have a graph with 3 x's or an x cubed, you will see 2 turns in the graph. Okay? Just like that. If I had a graph with an x to the 4th, it could look kind of like a w. Okay? So as that exponent gets higher and higher, you can see more and more, up to more and more turns in the graph. Okay? It's always 1 less than that exponent. Okay? So that gives you an idea when you're graphing of what to look for. Okay, and the last thing I want to look at for this section is finding a complete graph of the square root of x plus 20. Now, when you take a square root, what kind of number does it have to be when you take a square root to avoid imaginaries? Yep. Positive or 0. So in other words, it can't be negative. All right. So whatever you fill in for x, okay, under that root, you don't want it to be negative. Okay? This whole section. So can anybody tell me what they think the smallest x value would be that you could plug in? Like you couldn't do negative 100, because negative 100 plus 20 is only negative 80. It's got to be at least 0 or higher. Yeah? Negative 20. Yeah, negative 20 is the smallest value you could plug in for x. If you go negative 21, that's too small. Okay? You're going to take the square root of a negative. So negative 20 is the smallest x value. Any question on that? Why do you think that's important to know? How does what we just figured out going to tie in with the calculator? What do you think that negative 20 is going to be?
X.
Yeah, it's going to be my smallest x value that I can plug in. It's my x min. Or at least it gives me an idea of where I should set it. If you want it right on the edge of the screen, you could do negative 20. If you want to go a little bit more, just so the graph isn't right on the edge of the screen, do negative 25. X max. What's the highest number you can take the square root of? Yep, Andrew? 4. Can you take the square root of 5? Yeah, you can take the square root of 5. So 4 is not the highest. What's the highest number you can take the square root of? One what? Yeah, there is no highest number. X max could be as high as you want. You could plug in 1,000,000, take the square root of 1,020,000, plug in 1,000,000,000. There is no limit. So what should I set X max to? I don't want to go too high. I mean, 10 is probably enough that I'm going to get the idea of what this looks like. Now, when you take a square root, what kind of answer are you going to get? A positive or a negative with this symbol? Positive. If they wanted a negative, they use this symbol. They put a negative in front. Okay? So as far as what kind of answers am I going to get for y, they're never going to be negative. Okay? So it doesn't make sense to look at negative values. And then how high are the y values going to go? Well, let's look at what happens if I plug in the biggest x value that I put, 10. What's 10 plus 20? 30. And what's the square root of 30? About 5 point something. So I don't really even need to set my y max as high as 20. Okay? I'd have to be taking the square root of 400 to see a y value of 20. So really, probably setting it around 10 is good enough, and it's not even going to go that high. Okay? So I think I typed in my window. Now I need to type in the graph. To do a square root, press second, and then the x squared button. And type in x plus 20. Okay, and then hit graph. So there's your square root. The important thing to make sure you see with a square root is where it starts. Square roots always have a starting point, and then they curve in one direction. We could flip it. We could make it curve the other way. But that's basically how a square root always looks. Okay. Any questions on that one? Oops. I wanted to drag over my window, but it's not letting me. X-min, X-max, Y-min, Y-max. All right, so negative 25, 10, 0, 10. That's all you have to write down. Okay. Any questions on that one? Okay. So that finishes section 1.2. Okay, so really the new thing there on the calculator was calculating an intersection. Make sure you know how to do that. Okay, if you come to me on the test tomorrow and say, I don't remember the buttons to press, that's part of what I'm testing you on. Do you remember what I showed you on the calculator? Okay, so you do need to know that. All right, so the last thing we're going to look at is part of section 1.3. Which is on functions. And this problem that we did, the rent-a-car problem from section 1.2, that equation is an example of a function. And I used a couple of these names earlier, but the x value, okay, or the one that you plug in for, that's called the input. The y value is called the output. Or some other names for those variables, x is the domain. So when you think about domain, think about what makes sense. If x is number of miles you're driving, domain shouldn't be negative numbers. You can't drive negative miles. Okay? The domain in our problem was x values from 0, as high as you want to go, however many miles you want to drive. And then the range, that was the cost to rent the car. Same idea. The range there would never be a negative number because you're not going to pay negative money to rent a car. So we just try to use a little common sense when we figure out domain and range. And then a third name for them is x is called your independent variable and y is your dependent variable. Okay, all just synonyms for x and y. Any questions on those names? Okay. So the idea of a function, okay, not everything that you can draw on the calculator is a function. For example, if you drew a circle on the calculator, that's not a function. I'll tell you why in a little bit. But if you draw something on the screen and it is a function, then this has to be true. Every x value has exactly one y value. That's a simple way to say it. Every x value has exactly one y value. Every input has exactly one output. In other words, what that means in the context of the rent-a-car problem, if you tell me how many miles you're going to drive, I can tell you how much it's going to cost to rent the car. It's not like if you drive 50 miles, it could cost this or it could cost this. No. If you plug in 50 miles to rent the car, there's exactly one cost. It's not like there's two costs. Look at a circle. Let's say you let x equal 1. Well, in a circle, if x is 1, you could be up here. There's a y value there when x is 1. And there's a y value here when x is 1. That's not a function. Because when x is 1, you have two different places you can go. You don't have exactly one output. You have exactly two in this case. Okay, that's not a function. Okay, and there's a test, and it's called the vertical line test. Anybody remember that? Vertical line test? I'll mention that as the very last thing in a little bit. Okay. But that's the idea of a function. Every x value has exactly one y value. How about this? Let's say y equals positive or negative square root of x. If you plug in 16 for x, what do you get for y? You get positive 4, and you get negative 4. So if you plug in 16, do you get exactly one answer for y? No, that is not a function. I could make it a function just by getting rid of the minus sign underneath. Okay, that would mean ignore the negative answer. Okay, but that's a case where you plug in a value for x and you get two answers for y. Okay, we had a problem like that with the distance formula in the homework last night. Okay, not a function. All right, domain, those are the numbers you are allowed to plug into a function. There's two important things you have to be careful about when you're figuring out domain. Okay, two major things. One is square roots. You can never put something where I just circled that would be a negative. All right? You never want to end up taking the square root of a negative number. That's a problem. And the other thing is if you have a fraction. What number do you want to make sure is never in the bottom of your fraction? 0. So if I gave you a problem like this, 4 divided by x minus 1. What values, or what's the only value you cannot fill in for x? 0 is okay. 1. You can plug in any number you want for x. 3.5, negative 12.5. You just can't plug in 1, because then you divide by 0. So those are the two big things you want to look out when you're doing domain. Make sure you don't divide by 0. Make sure you don't take the square root of a negative number. So in the problem I just circled, if they asked for the domain, I would say all numbers except 1. That's what I would write down. And then the range, those are the answers that you get. Okay, so when you plug in for x, what kind of numbers do you get for y? That's the range. Okay, so let's try an example. Actually, I'll get to an example in a second. Unless the directions say otherwise, we're dealing with real numbers. In other words, we're not doing imaginary. Okay? And when we write something as a function, there's two different ways you can do it. Y equals, or this other one. Does anyone know how you pronounce what's on the left-hand side of that bottom equation? F of x. Yep, that's just another way to write a function. F of x. And it could be f of x, it could be g of x, it could be h of x. You can use any letter you want. Okay, so if you see f of x and it's confusing or you don't like it, you can change it to y. It means the same thing. You've probably seen f of x notation since like algebra 1. It's just another way to write it. Okay, so now let's see if we can find the domain and range for this. Okay, this one has a square root. What did I say about square roots? You never want to do what with the square root? You never want to take the square root of a negative number. So could I plug in 1 for x? No. It's negative. You say anything higher than 3. How about 3 itself? If you plug in 3, would this come out negative? No, then we're okay. So we can pick any number, 3 or higher. I'm not going to do the graphing part on the calculator. Unless we need to, the calculator can kind of help you to visualize it. So maybe we'll do that for the range, but I don't think we need that for the domain. So the way you write it, any number 3 or higher, is you write down a 3. We put a bracket. What that means is you can pick any number from 3, including 3. That's the bracket, up to infinity. Okay? That's how you write the domain. And we put a parenthesis on infinity because you can never reach it. Okay? You never put a bracket on infinity because bracket means you can include the number, you can reach the number, but you can't reach infinity. So any number from 3, including 3, up to infinity. If I did something like this, that means any number from 3, not including 3. So we start at like 3.000001 up to infinity. That's not what we want here. We can include the number 3. Okay, and let's look at the range. This is where I use the calculator to help me out. Okay, so I'm going to graph. Actually, I can just pretty much use what I have right here. Square root of x minus, and we'll make it a 3. Or you could just clear the whole thing and type it over again if you need to. I'm going to do zoom 6. I think that'll be good enough. That's good enough. And we can see that the x values start at 3, and they go to the right forever. How about the y values? The up and down. What's the lowest that it looks like this graph ever goes? Yeah. It goes to 0. Okay, and it will reach 0. And how high is the graph going to go? Infinity. It doesn't look like it's going up fast, and it's not. But it's just going to keep going up and up, curving very, very slowly. So the y values just get higher and higher. Okay, and that's the domain and range. Okay, domain and range, sometimes it's a little tricky for people to figure out. But sometimes the picture can help a little bit too. All right, let's try this one. Before I graph it, what shape is an x squared function? It's a parabola. So that gives us a little bit of a hint. Okay, on the domain, what numbers are you allowed to plug in for x? What numbers are you allowed to square? All numbers. You can square negative numbers, you can square positive numbers, fractions, decimals. You can plug anything you want in for x. There's no problem at all. So the domain, you could write all real numbers, or the shorter way is just to do it like that. Now range, that's up and down. Do parabolas go up and down forever? No. They only, they either only go up forever, or if you flip them over, they go down forever. Let's look at this one. So we've got x, I'm just going to clear it, x squared minus 4, the graph. And might be a little tough to see, but this parabola has a minimum, and then it goes up forever. Does anyone see what the minimum is? Yeah, it's at -4. That's the lowest that it will ever hit. So, and it does reach it. In fact, if you plug in 0 for x, you get -4 for y. That's the smallest number you can ever get. And what's the highest number? Infinity. Just keeps going up forever. I'm going to show you this just because I want you to see how to type an absolute value symbol on the calculator, because I haven't shown you that. It's pretty much the same problem we just did. We just absolute values around it. What does absolute value do to a number? Yeah?
So it's like how far away it is from 0.
It's how far away it is from 0, and it's always what kind of number? Positive. So what I'm going to do to insert an absolute value is I'm going to press second, insert. If I didn't do that, it's going to wipe out what I already have there. This might not even work, but I'm going to try it. I'm going to press math, and then I'm going to go to number. And the first option under number is ABS. That's absolute value. Now I have to type it in again anyway. So I'm going to type in x squared minus 4. I was hoping to be able to use what I already had.
Yeah, where's insert?
You don't even need to do it because it didn't work the way I thought it was going to. So you could just clear what you have and type it all over again. Don't even bother with insert. Okay. So math, number, absolute value. Okay, and again, it's probably easier to just clear it and just type it over from scratch.
Yeah, how do you do it again? Can you show us that?
Yep, go to math. And then the second column, number. And under that is the option absolute value. ABS is how it's written. Okay, now when I hit graph, it's going to try to draw a parabola, but remember, absolute value won't allow it to go negative. So the part right here that was negative before, it's like it's been flipped up, and now it's positive. So what did the absolute value change? Did it change my domain, or did it change my range? Yeah, the domain is the same. You can still square any number you want. But it doesn't go as low as -4 anymore. What's the lowest that it goes now? 0. It never crosses the x-axis, but it does touch it. In fact, it touches it in 2 spots. When you plug in 2 for x, or when you plug in -2. Those are the 2 spots where it hits its lowest value. Okay? So now we never go below 0. So the range is 0. How high does it go? Infinity. Yeah, it just keeps going up. So that's a bracket. Okay, so I just wanted you to see where absolute value was. So math, number, absolute value, and it's in the video too. So if you forget, you can look it up there too. All right. So the last kind of calculation thing is evaluating a function. So if they say to find f of 3 or f of 4, okay, something like this, all you have to do is take whatever number they give you and plug it in for x. I just want to make sure everybody knows that notation. Okay, so we're going to take a number that they give us, plug it in for x. I'm not going to do all 4 of these. Let's do f of 3. So if they want me to find f of 3, what number am I going to plug in for x? 3. Yeah. So I'm just going to change this to f of 3. And everywhere I have an x, I'm going to fill in a 3. So what's f of 3? Careful, not 9. 10. Because you've got to square it and add 1. That's all. So there'll be a couple problems on the test that are just like that. It's just evaluating for a value for x. I'm going to skip negative 2a. I'm going to do the last one, f of x minus 3. What am I going to replace this with now? What am I plugging in?
X minus 3.
Yeah, I'm going to plug in x minus 3. And what that means to do is x minus 3 times x minus 3. And you need to FOIL that out. Okay, so when you FOIL that out, you'd get x squared minus 6x plus 10. I combined it with the 1 at the end. X squared minus 6x plus 10. It's plus 9 plus 1, which is how I got plus 9. Okay, so that's evaluating. And then the last thing I already mentioned to you a little bit was the vertical line test. So not every kind of equation is a function. The only ones that are functions are ones that pass the vertical line test. I think I gave you this one as an example. I said if you plug in 16 for x, what do you get for y? 4 and negative 4. And we said that that's not a function. So you already saw that in the notes earlier. This is the part, I mentioned it, but I didn't write it down until now. So the vertical line test says that if you draw a function, and a vertical line only hits it once, then your graph that you drew is a function. If a vertical line hits your picture more than once, it's not a function. So circle, was that a function or not a function? Not a function. How about something like that? Function or not a function?
Not a function.
Oh, wait, no, it's a function.
So if I put a vertical line,
Oh.
does it ever hit my graph more than once? No. No matter where I put it, it only hits the graph one time. How about if I did something like this? Flip that around a little bit. Not a function. Because vertical line hits my graph more than once. Okay, that's the vertical line test. All right, so a lot of questions in the homework tonight are going to be similar to some of the calculator stuff we did. So you might not have to write anything down. For a lot of them, it might just say, practice setting your window. Just put down, on graphing calculator or something like that. Okay. Does everybody have the vertical line test? Okay. All right. So the first part of what we did, section 1.2, is page 20. And then the second part is page 30. A lot of the questions there are like, yes, no. Is that a function? You just have to write yes or no. So there's not really a lot of problems that require a lot of time. It's not like it's going to take you 20 minutes a problem. Okay, so we'll go over that first thing tomorrow before the test. Then after that, we'll do the test, and then whatever questions you have, if you want to come see me before school tomorrow, that's fine. Just remember, I won't be after school for extra help today.